Okay students, now we see the next series which is Lorentz series. See the statement, if f of z is analytic in a ring R bounded by two concentric circles C1 and C2 of radii R1 and R2 where R1 greater than R2 with center at A, then for all z in R we have f of z is equal to a naught plus a1 z minus a plus a2 z minus a whole square and so on plus b1 by z minus a plus b2 by z minus a whole square and so on. Here we write the constants a1, a2 and so on, b1, b2 and so on. Here an is nothing but 1 by 2 pi I integral over c1 f of w dw by w minus a whole power n, and bn is integral over c2 same constant f of w dw by w minus a minus n plus 1. Okay ma, first we see what is the given. This is the given part. We are going to prove this f of z. Ma. For this purpose, first we observe what is given in the data. F of z is analytic in ring R. Ring R bounded by two concentric circles. See the diagram. C1 is outer circle and C2 is inner circle. R is the ring shaped, this one, the region between C1 and C2 circles. Okay, here R1 is the two are concentric circles. C1 and C2 both are concentric circles. That means both have same center. So the center is given as A. So C1, C2 have same center and radius of C1 is R1. That means from A to center to this border. Okay, this is R1 and R2 is center to C2 border. Now this is R2. No doubt C1 is outer circle. Its radius is greater. R1 is greater than R2. That is given in the data. Okay, this is the given data. Using this data, we are going to show that f of z is like this in the series form. This series is called Lorentz series. But here we use a1, a2 constants. This a1, a2 constants, we get these values as an is equal to 1 by 2 pi I of this integral. And C1 circle meeda mana integration తీసుకున్నప్పుడు a1 find out చేస్తున్నాం. Next similarly bn value వచ్చేసి integral over curve C2. We see how can we get these values. Okay, here a C dash is any curve in R encircling C2. C dash తీసుకుంటున్నాం, ఇది C2 ని కవర్ చేసే విధంగా తీసుకుంటున్నాం అని చెప్తున్నాం. ఓకే మా, let the proof ma. Consider a cross cut PQ and f of z is analytic in the region R dash bounded by PQ. Z is any point in R dash. Okay ma, you let the cross cut PQ, then R dash is the region bounded by that PQ. Totally you have PQ curves, C1 curve, C2 curve and C dash curve are there. Now f of z is equal to 1 by 2 pi I integral over, we have already f of z is 1 by 2 pi I integral f of z dz by z minus a. That is using the Cauchy's integral formula. But here not only one curve, integral over c, that c means here PQ curve and C2 and QP and C1. Now f of z is integral over C1 minus integral over C2. ఎందుకంటే ఈ రెండు ఆపోజిట్ కర్వ్స్ కాబట్టి PQ అన్న QP అన్న సేమ్. సో ఈ రెండు టర్మ్స్ క్యాన్సిల్ అయిపోతున్నాయి. నౌ యూ గెట్ ఓన్లీ ప్లస్ ఉన్నది C1 కర్వ్ వచ్చేసి ఫస్ట్ ఇంటిగ్రల్ మైనస్ C2 ఓవర్ C2 ఇంటిగ్రల్ వచ్చేసి సెకండ్ ఇంటిగ్రల్. Totally we have f of z is equal to 1 by 2 pi I integral over C1 f of w by w minus z minus integral over C2 f of w dw by w minus z. Let it equation 1. Now we see the first integral value. First you find the integral value over C1. Then we find integral value over C2. Now we see the first one. Here C1, C2 described anticlockwise. Okay ma. Now you see this 1 by 2 pi I, this one ma, I am taking 1 by 2 pi I integral over c1 f of w dw by w minus z. I am taking first integral in equation 1. Now this integral is equal to 1 by 2 pi I f of w by w minus a dw plus z minus a 2 pi I integral over c1 fw by w minus a whole square and so on. As I told in the Taylor series లో చెప్పినట్లుగా ఇక్కడ మనం ఇంటిగ్రల్స్ అన్ని తీసుకున్నాం. ఇట్ కెన్ బి రిటర్న్ యాజ్ సిగ్మా n is equal to 0 to infinity z minus a whole power n by 2 pi I integral f of z w dw by w minus a whole power n plus 1. Now you see here this is in sum of here z minus a power n is there. Okay, here z minus a power is there. See here z minus a whole power n is there. What is the remaining here? Same sigma, same z power n into what is the value into 1 by 2 pi I integral f of w dw by w minus a whole power n plus 1. ఈ z minus a whole power n తప్ప రిమైనింగ్ వాల్యూ మొత్తాన్ని మనం an అనుకుంటున్నాం. Now what is an? 1 by 2 pi I integral over c f of w by w minus a whole power n plus 1 dw. Now this integral value is equal to this one, equation 2. Write what is an. What is an? I have already told 1 by 2 pi I so on. Now here we write, here you write what is an. Already I told an is 1 by 2 pi I integral over c1 f of w by w minus a whole power n dw. This is on integral over c1 an is integral over c1. Then let the second value 1 by 2 pi I integral over c2 f of w by dw. Okay, for c2 w minus a less than z minus a, w minus a by z minus a less than 1 అంటే ఇది x ఫామ్లో ఉన్నట్టమ్మా, x less than 1 అని. Now take 1 by w minus z is equal to 1 by w minus a minus z minus a, let z minus a as common, ఇలా z minus a as common 1 minus w minus a by, అంటే w minus a ఒక సింగిల్ టర్మ్ అనుకుంటే మీరు z minus a కామన్ తీస్తున్నారు, z minus a కామన్ తీస్తున్నారు మీన్స్ 1 minus w minus a by z minus a. ఓకే అమ్మా, ఇట్ క్యాన్ బి రిటర్న్ యాజ్ ఇన్వర్స్ 1 by z minus a అలాగే ఉంచాము, దీన్ని పైకి తీసుకెళ్ళాము 1 minus w minus a by z minus a inverse, but w minus a z minus a less than 1, so this is less than 1 ma, కాబట్టి expand the series. Now use 1 minus x inverse is equal to 1 plus x and so on, 1 plus x square for x less than 1. Here we observe w minus a by z minus a less than 1. So this is in the form of 1 minus x inverse. You write this expansion for this one. In place of x, in this formula, in place of x we have w minus a by z minus a. Now expand this series by using this formula. We get 1 by z minus a, 1 plus and so on. Okay. Now this integral, consider this integral and now this integral is equal to 1 by 2 pi I integral over c2 f of w dw by z minus a, that means this one, these terms we get. Okay, these terms we get, this is 1 by w minus z ma. You observe ma, here this is 1 by w minus z, it value is this one, substitute 1 by w minus z like this one. Already we have f of w dw is there, 1 by w minus z లో ఈ టర్మ్స్ అన్నీ ఉన్నాయి కాబట్టి ఆ టర్మ్స్ అన్నీ సబ్స్టిట్యూట్ చేస్తున్నాం ఇక్కడ. ఓకే, ఆఫ్టర్ సబ్స్టిట్యూషన్ యూ గెట్ సిగ్మా bn z minus a power n, which is equation number 3. That means this integral value is this one. Substitute in equation 1 this bn and an, that means equation 2, 3 in 1, we get this series, substitute this, we get this series ma, which is called Lorentz series. You observe there are two parts here, positive powers, this part is called analytic part, there is negative powers, this part, second part is called principal part. Suppose there is no positive power part, it is reduces Taylor's theorem. It is reduced.